let's get into aggregation. It's actually one of my favorite parts about MongoDB. I have a lot of favorite things when it comes to databases. This is a favorite thing as well as the other things that I was favoriting before, also favorite. All right, we're gonna be talking about, going back here, aggregation. This is one of the first things that actually got me like really excited about MongoDB. It felt like I could do, I don't know, it felt like I was able to get interesting and unique insights out of my database that I felt like I couldn't have done previously. So here's my example of when I used this before. I used to work at a like classifieds type website. So like you can picture like Craigslist. I didn't work at Craigslist. I worked at a different company that did similar types of thing. And we had a rule that people could only post 5 ads, otherwise they had to pay money to be able to post more ads, right? That's kind of the monetization strategy for this company. But we'd have people that would just go in and create multiple accounts, businesses, right? People would dishonestly circumvent the rules and go and post multiple classifieds. And so I actually used this technique to go in and find ads that had the same address in them, and then I was actually able to automatically ban people that were posting multiple ads across different accounts, right? Again, I was a brand new developer. I was writing PHP 4 at the time, right? And this felt like a superpower to me that I was able to write this like automatic banning mechanism for people that were circumventing the rules. And it's through this power called aggregation. I'm going to show you the new way of doing this in MongoDB called the aggregation pipeline. This is the preferred way, the better way to do it. But there's an old way of doing it called MapReduce. And if you're a functional programmer and you like those kind of things, that sounds very appealing to you. It's still available. You can still do MapReduce. It's just slower, a bit harder to understand. So we're going to focus on the aggregation pipeline, but also know that there is the MapReduce framework out there as well for doing MapReduce against MongoDB. So what the aggregation pipeline allows you to do, it basically allows you to take your data and slice it up into various different buckets, and then you can kind of do averages, you can do additions. Basically allows you to derive insight from your data. It allows you to combine them and unwind them in interesting ways to kind of figure out, I don't know, anything that you want to know about your data. So what I'm going to show you right now is I want to find out how many puppies are in my database, how many adult dogs are in my database, and how many senior and super senior animals are in my database. This is possible through the aggregation framework. So let's give her a shot here. We're going to say db.pets.aggregate. And then it does this in stages, right? So you can give it multiple different stages of like, do this first, then do this, then do this. So we're going to give it one stage first of bucketing. So the bucket allows you to break we're going to break our pet collection down into buckets by age. So with the bucket here, we're going to say group by $age. So the $sign is just saying that's the name of the field that I want you to look for. So $age is going to be grouped by their age. Okay. Then the boundaries, this is going to be defining the kind of boundaries of where we want to put our dogs. So the first one is going to be down to 0, right? So anything between 0 and 2, I don't know if I'm correct, but I'm asserting anything between 0 and 2 I'm going to consider a puppy. Everything from 3 to 8 I'm going to be considering an adult, and everything above that I'm going to be considering a senior animal. So 0, so it includes the bottom and excludes the top. So 0 to 3, so that says everything from 0 to 2 will be in the first bucket. Everything from 3 to 8 will be in the adult bucket. And everything from 9 to 15 will be in the senior bucket. Then we have to give it some sort of default, because we do have some animals that are even older than that. And we're just going to put those into like very senior, or you could also call that like 16 plus, whatever you want to call that last bucket. Basically, you're saying anything that doesn't fit in my boundaries, stick in this other bucket. And then you have to define what kind of output that you want to put in there. I just want to count, but if you wanted to like I don't know, you can put the animals into the buckets and then do more aggregation on them later. There's a bunch of stuff you can do with the output here. It's kind of like the projection that you want out of your animal here. So the output, all I want is a count. And I just want you to keep a running total, so I'm going to say sum1. So that means for every animal that you find in this bucket, increase the count by 1. I can never keep these damn curly braces straight. So that's for bucket. That's for the one that contains bucket. And then I want to close the array and close the function call. Yes, got it. First time, like a champion. All right, so ID, this corresponds to the boundary, right? So from 0 to 2, I have 1,071 pets. From 3 to 8, I have 3,218. From 9 to 14, yeah. So I guess 16 plus wasn't right. It was actually technically 15 plus. Anyways, in my super senior category, I have 2141. In fact, let's just fix that so I can feel good about myself. So in this 15 plus one, so that's 15 or above, we have 2,141. Okay, so that's interesting. That's actually not technically what the question was. The question was how do we figure out how many senior dogs, right? So I actually, this is all the senior animals. So I've bucketed all animals in the pet collection, not just dogs. So I actually need to add another stage to this. And the way I'm going to do that, well, I'm just going to copy and paste it from here and explain it. All right. So this bucket, this is the same one, except it's called very senior here, right? We add another stage. We're going to put that stage before the one that we go and bucket them, and we're going to just say, hey, match everything that's dog, drop everything that's else. And so that's the first stage will be that match stage. The second stage will be the bucketing stage. And so you can see here, now these numbers are much smaller because we're just looking at dogs. We're not looking at the rest of the pets in the collection. So let's add one more thing. Let's say that for whatever reason we wanted to sort these by how many, which one had the most, right? I mean, obviously we can do that visually, but that's less interesting. Let's do it programmatically and add one more stage. So the match stage is the same, the bucket stage stays the same, but we're adding one more stage at the end. And we're just saying sort by count descending, which basically says we're going to have the one with the most first, second most second, so on and so forth. So you can see here we have the most adult animals, second most senior animals, third most very senior animals, and the least amount of puppies. This is just one very simple use case of the aggregation pipeline. This is a infinitely flexible, you can do lots of really amazing things with the aggregation pipeline. I just wanted to kind of like get your head around it a little bit so you can think like, hey, I need to derive this insight out of my data. I need to figure out, you know, how many reptiles were born on Tuesdays, right? I don't know, stuff like that. That's stuff that the aggregation pipeline could totally figure out for you. You're kind of getting into almost like data, actually not kind of, you're literally getting into like the data science part of what you can do with databases, which is kind of some of the cool stuff. Like I'm not a data scientist, but anytime that you let me do data sciencey stuff, I feel like a wizard. So I like doing that kind of stuff.